Now moving forward, resizing, rotation, translation. So I hope you guys are aware about their definition because it's just a very basic terms. Yes, yes. I'm very happy, guys. You are very interactive in a session. It really motivates me. So okay, moving forward, resizing, rotation, and translation. So these are all the basic steps we perform during the image processing. No, first we will cover it from the basic scratch. So why we need resizing, rotation, and translation? These are the main thing. You know, resizing is to do resize of the image. You have a big image, you just resizes it to a in different image size. So can you guys tell me what's the use of resize? Why do we use it in machine learning? In a chat box, please type in a chat box, guys, if you know why we use resizing, although it is visible on our screen. Okay, 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 cool. We will see it. So guys, whenever you are building a computer vision model, okay, reduce computational cost, yeah, that's correct. So I will explain it. So whenever you are working with a computer vision models, you need input in a fixed size. You can I can see some more responses. Same size input output, reduce cost. uh, Wait a second, Anushka. Same size input and output and reduce cost. Okay, okay. I think you are in little confusion. So we will see it. So whenever you are working with a computer vision model, you need image. You cannot fed a different image sizes. So suppose you gathered some data from the internet for your computer vision model. The images are of size. Some are in HD, some are in 1028 some are into 400 into 400 size. So you cannot fed the variable size inputs into your model. You have to make sure that all the images are of the same size, then only you can proceed further, then only you can fed these images in your classifier. So that's the need of the resizes function. So what we basically do whenever we are working on any model, we basically resize it. The data set which we have, we basically resize it to us something that we want. So we can if we have multiple images like 1024 dimension, 400 to 400 dimensions, so we will resize it to a fixed size so that we can feed this thing in our model. The second thing is to reduce. Am I audible? Am I audible, guys? Okay, cool. Okay. So the second advantages of resizing is to reduce the computational cost. Suppose you are working, we will take that first example. Suppose you are working on a face detection model and you have different images, 1024, 1024, 400 into 400, 500 into 500. So so my question to you guys is, so what the dimension you will prefer for a image process for a face detection task? Are you guys aware of it? Can you take a guess? 400 into 400, 200 into 200, or something else which you have? Yeah, the dimension of the image, I'm asking. 124 into 124 into 3. Yeah, yeah, now I will take it. I will now. Okay, okay. So now we can take, there's no any hard and fast tool to uh, know what size works with your model. What you can do, you resize the function, you resize your image, and you see by your eyes, you observe it, and then you if you can see the image, that you can, yes, you in this image you can figure out, yes, we can classify a face here, then obviously your machine learning, the computer vision model can also perform the same task, because you guys are aware of that, that computer, the CNN model works as per your brain, just like your brain. So that's the intuition you can got. Basically we prefer to use 200 into 200 for a face detection, but we can also increase it or decrease it depending on our need. If we are using a high dimension image, we have a greater matrix, and that's increase your computational cost. So we need to do a resizing too. So in a resizing function, we will see, we will have this resize function. This is very simple. We have we have to give img, the image, the dimension which you want, and the interpolation. Now we will see, guys, what is interpolation. So do you guys know what is interpolation? Just yes or no. I'm not asking the definition. No, no. Okay, 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 guys. So let me tell you something. Okay. So suppose you have this image, okay, and this image corresponding to this matrix. So we have value here, row and the column. Now you want, now you resize the image. So for resizing, you have to add some more pixels here, right? So suppose this is the bigger matrix you have. Now you have to assign some pixels here. If you are increasing the size, so how you would assign the pixels? So that is called as a interpolation. Basically in a DSP, we have two things: decimation and interpolation. Decimation is basically downsampling filter, and interpolation is basically upsampling. So basically what I mean by downsampling is, suppose you are decreasing the size of the image, so you need to uh, drop some pixels. So how will you do that? So that's a so that is one of the thing. And how will you increase the size? So that is called interpolation. So in OpenCV we have only given interpolation name. So we have different kind of interpolation to do the task for you: nearest interpolation, linear interpolation, area interpolation, cubic interpolation, and the Lanczos. So all these interpolation have different advantages. So first I would like to tell, what does a nearest interpolation do? Suppose this is a matrix. Okay, so suppose this is your matrix and this is the value 5. Now you increase your matrix size, then you need to interpolate a new pixel. So what a nearest interpolation do, it will basically take the pixel from your nearest neighbor. So okay, so what I'm saying, so you can take this you need to interpolate this pixel using your nearest neighbor. So that is called nearest interpolation. You can use a bilinear linear interpolation also. So these are all the basic advantages of using different type of interpolation. The nearest interpolation is very fast but not that efficient, because what you are doing, you are just uh, uh, interpolate by using the nearest pixel. And inter area is based on area interpolation. So basically it take, wait a second, so it take that area and corresponding to it, it will interpolate the new pixel. So what's the major advantage of using the near? We basically use area interpolation to shrink the image. That is for your information that you need to remember. And the cubic and the linear is for when zooming is required. The cubic is much better because in this we are going to use a 4 into 4 pixel neighborhood. So it will take a 4 pixels here, and then it will take the average and interpolate accordingly, and then in okay, and in a linear interpolation you will use a 2 by 2 filter, 2 by 2 kernel. Sorry for the disturbance, guys. So does the interpolation same as zooming? No, interpolation is a method to interpolate new pixels, because if you are zooming, then you need to add some more pixels, right? In your image. So how can you do that? You will use an interpolation method. So that is the thing. Do you guys have any doubt about interpolation? Ask me right now, because I am free to take any doubt. You can write your doubt in a chat box. But this is just a overview of the interpolation and also the working. So I guess you don't have any doubt. So this is the image. In my initial image, I resizes into a 1500 into 1500 dimension. Okay. Clear. Okay. Okay. So I use the inter underscore cubic method. So this is how the image looks like after resizing. The image loses its quality also while we do the enlarging. So just remember that area interpolation is used to shrink the image, and cubic interpolation and linear interpolation is used for zooming purpose, and cubic is more efficient, and nearest interpolation can be used for anything, because it's just taking the nearest pixels, and this is very fast because we are just doing the nearest we are just taking your nearest neighbor, and but not that efficient. Okay. So moving forward to a rotation and translation. So just give me a one word. Why do we use rotation and translation? What's the need of rotation and translation? Guys, you can type in a chat box when data is less. Yes, 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 yes. Yeah, that is the correct point. So suppose you are building an model, but you have only 100 images. So now what you want? Yeah, 100 images is not sufficient, because deep learning models are very data hungry. They need a tons of data to uh, understanding the feature, to understand the features, to understand the image. So that's why a rotation comes in a play and translation comes in a play. Both are the famous basic image augmentation technique, and one of the most used data augmentation techniques as well. So we will see how we can do the rotation translation. So uh, for rotation, we will use this matrix. This is for the scaling of the pixels. This is for the translation of the pixels, and this is for the rotation of the pixels. So every look at here. So now you have a matrix of the image, which in which you have different pixels. So this pixels x, you take it here, and you will do the you will give the theta in your model. This is in a polar coordinate, and you will get your new pixel. So your new pixel corresponding to that rotated image. So that's the simple mathematics behind it. We use a little calculus here. So this is how our rotation matrix look like. Alpha is scale dot cos theta, beta is equal to scale dot sin theta. So it's just a mathematic thing. Okay, so we will see how we can implement it. So here you can see we define a function rotation in which we specified the image, we specified by how much angle we have to rotate and through what point we have to rotate it. So basically img.shape gives you the dimension of your current image. So if suppose this image is 500 into 500, then you will get height 500 and width 500. So you need two things here. First is rotation matrix 2D, that is this, which you can which you do not have to worry about. OpenCV as a function to make sure that you get the rotation matrix. And and the wrap affine function. What does wrap affine function does? It basically convert your pixels using the rotation matrix function to that to the pixels corresponding to that image. So this is how a rotation function look like. So this is an image I have rotated using the 45-degree angle. I didn't give any rotation point. So it is basically taking the center. Yeah, you can see how you can. So suppose this is 400 and this is 400. The center coordinate will be 200 and 200. So here I specified if you are not giving any rotation point, then it will take as a center. So how you can hard code it? Height divided by 2, width divided by 2. So this is all about the rotation function. And similarly, we have a translation matrix. So translation function. So in translation function, we have a translation matrix, and same thing we will do here. We create the matrix using np dot using this function, using NumPy, the library. I hope you guys are aware of the NumPy as well, and the dimension you will give, and use our wrap affine function. So this is how a translation looks like. So we will share this OLAP file also at the end of the session, so you can check more things from there.